And this video is about the zero product property. We're going to talk a little bit about how to solve problems when they have more degrees than just one. So, um, we've talked a lot about how to solve problems, something like 5x plus 4 is equal to 15. Um, and you know that you would isolate the linear variable here, so we get 5x is equal to 11 and divide both sides by 5. And so x is equal to 2 and a fifth, or 2.2, right? But what do we do if we have a situation where we have a quadratic term, right, as well as our linear term? So here's our linear term for b, but then here's a quadratic term as well. And so today we're going to talk about how to manage, or how to try to think about being able to solve these kinds of problems too. So one of the things that becomes complicated if we try to just come in and solve this quadratic problem is that if I try to isolate this variable, this 3b, by moving this b squared onto the other side, now I've got 3b on one side, but I also have a variable on the other side, right? I've put this variable now on both sides of the equation, and so that's not going to get us closer to a solution. I could maybe, so that's not going to work. I could maybe, I don't know, maybe I want to divide it by b. Maybe I want to find some way to like divide by b. But how do I know that whether the b is equal to 0, right? And b might be equal to 0. I don't know. And if b is equal to 0 and I divide by b, I just broke algebra. So I can't divide by a variable as like my step, because I'm not going to be sure that what results is true, because I know that if I divide by 0, I'm going to get an untrue answer, right? I'm going to get an answer that's outside the scope of the laws of algebra. So I can't do that either. But what if I sort of hacked it a little bit? What if instead of dividing by b, I thought of a sneaky way to take b out of, if you will, this? What if I factored it? So I said, okay, well, b squared plus 3b, they have a common factor of b, so if I factor out the b, I'm left with b plus 3 equals 0. And so now I have two factors, two things that are being multiplied by each other, equal to this 0. But how, Kate, you're asking, can I use this information to be able to solve? And so that's where this zero product property comes in. The zero product property tells us that for any real number a and b, if I multiply them together, right? If I multiply a times b and I get 0 as an answer, that's only going to happen if either a is equal to 0 or b is equal to 0. So let's think about that for a second, right? Let's let a equal 3. So 3 times, I'm going to do this like elementary school, 3 times box equals 0. What has to go in the box? Right, b has to be equal to 0 in order for that to work, right? Well, okay, fine. What if b is something else? What if b is 5? Well, then 5, or I guess I should say box times 5 would give me 0. Well, in that case, a would have to be equal to 0, right? If b is equal to 5. So one of them has to be equal to 0. A has to be equal to 0 or b has to be equal to 0. They could both be equal to 0, but at least one of them has to be equal to 0 in order for a times b to give me 0. Which means that if I can figure out what value would make a the same as 0 and what value would make b the same as 0, I know that those are possible solutions. Those are possible values for which a times b would give me 0. This works for any number of factors, and we're going to take a look at um, how that ends up looking out. So I'm going to take a look at this factor. So if I look down here, a is my first term, right? This is my a. And b is this second term, right? And so in order for a times b to equal 0, I know that either a is equal to 0, and so either a is equal to 0, and in this case, a is x minus 3 is equal to 0. So if we have this case, the a is equal to 0 case, then x minus 3 is equal to 0. And now I can just solve for x. So I just add 3 on both sides. So x could be equal to 3. So I can check that if I plugged that in. 3 minus 3 is 0. Times 3 plus 4 is 7. 0 times 7 is 0. Okay. So that's a possible answer. 3 is a possible answer. But what about this other case? What about this case here where b, this x plus 4, is equal to 0? So let's figure out this b equals 0 case. So if b is equal to 0, well then x plus 4 is equal to 0. And so if x plus 4 is equal to 0, I'm going to subtract 4 from both sides, so x is equal to negative 4. So it looks now like there's two possible solutions for this problem. I'm going to check both of them and see if that's true. So I'm going to check the x is equal to 3 case first. So 3 minus 3, the quantity, times the quantity 3 plus 4. Is that really going to equal 0? Well, that would be 0 times 7, and that does indeed equal 0. So that would work. And then I'm going to try this, the second case, the x is equal to negative 4 case. So I'm going to plug that in. So negative 4 minus 3 times negative 4 plus 4, is that equal to 0? So that's negative 7 times 0, and that is indeed equal to 0. So what that means is I have two possible solutions for this quadratic equation. And those two solutions are 3 and negative 4. Again, this can work for any number of factors. Here, if I've got 3 factors, I've got a times b times c is equal to 0. Well, that's going to be true if and only if either a is equal to 0, b is equal to 0, or c is equal to 0. So let's try the cases. So if 6b is equal to 0, that's one possible solution. Or if b plus 5 is equal to 0, that's another possible solution. Or if b plus 2 would be equal to 0, that would be another possible solution. So I can take each of these factors. If any one of these factors is equal to 0, the whole thing becomes equal to 0. So solving for each of these factors, here we would end up with b equals 0 for my first outcome. Here we would end up with b is equal to negative 5 for my second outcome. And here we would end up with b is equal to negative 2 for my third outcome. So I could check those, right? I could plug in 0. So for 0, I would have 6 times, for b equals 0, I would have 6 times 0 would be 0, times 5 times 2, and that would give me 0. For b is equal to negative 5, I would have negative 30 times 0 times negative 3, and that would give me 0. And for b is equal to negative 2, I would have negative 12 times 3 times 0, which would also give me 0. So here I have 3 powers of b, right? This is a cubic function, or cubic equation, I should say. This one over here was quadratic. It had 2 factors of x. So here I've got 3 factors. I've got 3 solutions. That are possible. Okay. Please try your hand at the short sheet that I attached with this, and we'll talk about this more in class. Thanks so much.